Good afternoon and welcome to the Data Analytics and Analysis Trends in 2015 webinar. Our presenter is James Graham and I'm going to hand over to him in just a moment, but before that I'm going to run you through a few housekeeping rules just to help the webinar go smoothly. It's very simple items. Just to let you know that the slides as well as the recording will be available and sent out to you in a follow-up email. We ask that you allow a week for this to come to you. The slides will be there to view on our SlideShare page. The recording will be on our YouTube channel. When the webinar finishes, a post-webinar survey will pop up, and I just ask that you give it a few minutes of your time to give us some feedback so that we can improve our services to you. As you listen to James speaking, you might have some questions that you think of, and if you look at the bottom of your control panel, you'll see a little questions box, and this is where you can chat with us through the session. You can type in comments there or questions, and right at the end of the session, James will allocate some time to answer your questions. So thank you for being here, and I'll hand over to James now. Thank you.
Good afternoon, everybody. My name is James Graham, and I'd like to just very briefly give you a couple of minutes introduction about what I do, and then hopefully be able to share some information with you that will be useful to you in looking at data analytics and trends in data analytics. My background is international, multinational organizations. I had 12 years in senior management. As you can see from the map of the world, I've worked in a number of different areas around the world. I've been in management consulting since 1993, specializing mainly in strategy formulation and execution, and that involves a lot of work with data. Strategy is a data-driven discipline at the end of the day. So what I'm going to share with you today really is two sets of information about data. Firstly, a little bit of information about the development of data analytics, where it came from, some key points. Then I'm going to talk to you about what we call big data and small data. Big data is a recognized term. I think most of you will probably have heard of that. Small data is my way of differentiating data that's not big data from big data. We'll look at some of the standard big data tools. I'll try and give you a little bit of background about those and explain a little bit about what's involved on that. And then I'll talk about some of the big data trends for 2015, 2016. Following which, I'm going to give you a demonstration of three small data tools which are very useful to the working manager or anybody in a supervisory role. And then at the end, as Shuri said, I will allow some time to answer your questions. So what I suggest is, when I'm talking, if you have any questions, please type them into that chat box at the bottom, and we'll capture those. And then at the end, I'll work through those questions and give you my opinion on those. And just to reconfirm, we are recording this session just so everybody is aware of that. So let's talk about the development of data and data analytics. One of the first key dates is the 1950s. The 1950s were when people started to get to grips with programming languages. Obviously, computer hardware is very important, and there have been some rapid developments in hardware over the last 50, 60 years. But equally, the languages that work on top of the hardware are what make generally programmable computers useful to us. And the first two languages of note really in the 1950s were Fortran and COBOL, which started to focus on business applications as opposed to pure scientific applications. In the 1960s, this was the era of the business computer. So in the 1950s, computers had mainly been used for scientific research, but once Fortran and COBOL had been written, business started to say, we want a slice of this action. We now want computers that enable us to actually use these languages and which are dedicated to producing quick, fast and usable results. So another key point around that time was that the IBM 360 computer was launched in 1964, and that spawned a whole range of what were known as mini computers, although they still took up most of a whole room, and these machines were used for business purposes. In the 1970s, the Unix operating system was invented, and this was coupled with the emergence of supercomputers, allowing for the first time people to start to tackle really, really large pieces of data. So in a way, one can start to say that the ability to process big data dates back to the early to middle 1970s, although in business it's been a trend that's emerged more recently. But back in the 1970s, organizations like NASA were using big data for the various programs, the Space Shuttle program and other programs that they were involved in. Then in the 1980s, this was very much the decade of the personal computer. IBM and Apple and a number of other organizations started to build computers that were small enough to fit on the desktop, even though they were very expensive. They were accessible to companies who were prepared to pay that price. And in effect, that allowed the democratization of data. You didn't any longer have to rely on a data processing department to deal with these things for you. You could actually gather and build your own small databases and spreadsheets and other kinds of data. So if 1970s saw the emergence of big data, the 1980s was the start of the sort of accessible small data available to the line manager. In the 1990s, we saw even more democratization of data in the advent of easier to use systems like the Apple graphic operating system, which came out in the late 1980s, but really developed in the 1990s. And of course, Windows, the Microsoft version of the graphic user interface, was invented in the 1990s and became popular with several different versions. So finally, the 2000s and the 2010s saw the advent of big data systems and big data maturity as organizations developed the infrastructure and also the know-how of what they wanted to achieve and what they wanted to do with big data. So that gives you, I guess, a rough timeline of how we got to where we are today. And the sort of parallel development of the big data systems and then also the personal computer systems, the personal computer software became more and more powerful, explains why big data and small data are both very useful to organizations, although they're quite different in the nature of what they do. So let's have a look at the differences between big data and small data. We'll start off with big data. These days, the definition of big data, there isn't a precise definition, but if you were to sum up the different views on it, it's basically a way of describing large-scale, complex systems that produce an enormous amount of data. And you'd usually start measuring big data in tens of terabytes up to petabytes. Now, petabytes, to give you a kind of explanation of what that is. If you recorded 1 petabyte of MP3 files of 128 kilobyte resolution for an iPad, it would take you 2,000 years to listen to those tracks if you didn't have any gaps between them. So we're talking about massive, massive amount of data. And some examples of this kind of data would be the behavioral data captured on search engines, social networks, data mining. Another thing, for example, images backed up or stored on social network sites. All of these very, very quickly get into the petabyte scale of big data. So we're talking about huge, huge data on very often far too much data for a single system to deal with it, and so it's often typically spread across several systems which are interrogating and mining that data from different perspectives. So this is not a trivial investment. It's not a question of going down to Sheriff DG and buying a computer and setting it up. We're talking about a very, very major investment, and also a very, very high degree of skill in terms of data science in setting up the data and also the mining of the data. So once again, if anybody has any questions to ask, you do feel free as we go through to type those questions in the box, and we'll get to those as we come towards the session end. Now, if that's large data, what would we consider small data to be? Well, small data is obviously smaller systems, simpler systems. It may still be on a mainframe computer or a mini computer, or it could be just kept on a small network or even on a single computer. Normally, we'd be dealing in thousands, tens of thousands, hundreds of thousands, or even millions of records. And typical examples of that could be anything from customer records to sales records, sales invoices, building access records, and security systems. So the attraction of small data to most managers is the ability to capture and download records into some kind of manipulation tool, and I'll be demonstrating some Excel tools later on, and being able to get information on the desktop quickly for either problem solving or recognizing opportunities or other purposes. So that's mainly the difference between big data and small data. Let's move on and have a look at a description of three of the different tool sets: Descriptive Analytics, Predictive Analytics, and Prescriptive Analytics. Three words that all have the same ending but have different meanings. Let's start off by talking about Descriptive Analytics. You can see that I'm using here an image of a motor car rear view mirror. And that's a deliberate metaphor to show that descriptive analytics is historical data that we've captured. Maybe very, very large. It may be millions and millions of records, such as navigation records from a website. And we're looking back to see what happened. We take that big data and we manipulate it by using data science techniques to provide useful nuggets and insights of what happened. At the simplest end of this kind of descriptive analytics, you may have things like year-on-year statistics of sales. That may be mined from enormous amount of records and presented as a simple bar graph in a presentation, but it would still be considered as big data. It may also be much more complex than that. So for example, governments may be collecting data about demographic trends in a country or a region and may be mining that for different purposes. But the common thread with whatever is being described is it happened in the past. It's not predictive and it's not future-based. Having said that, predictive analytics takes the descriptive analysis and then applies various algorithms. Again, the algorithm programming requires data science or econometrics qualification, and it uses a probability approach to try and work out what may happen, looking at present trends and past trends and predicting that into the future. In other words, it's filling in the blanks in the future based on what happened in the past. Now, as we all know, the banks always say investments can go down as well as up. So predictive analytics is never really a true prediction of the future, but it does allow you to take a probability-based view of what may be the consequence of making a certain decision. So, for example, banks use this kind of information to look at credit scoring. What will happen if credit's extended to a company or to a person? Is it likely they will be able to continue to support that debt and make sure that they make those payments on time? Another use of predictive analytics is looking at forecasting supply chain requirements, where organizations are able to look at past consumption, past trends, allow for various constraints going forward and predict those into the future, helping them to decide whether to upscale or downscale those requirements. Again, if you're running a website and if you have millions of customers, it may be that a new product will be attractive to only a very small percentage of those customers, and allowing you to focus in on that very, very small data will obviously save you time and effort, and also keep customers happy because they only get offers targeted to them. Predictive analytics, again, is a way of increasing the probability of getting the right offers to the right people in the right time. There are also many other versions of this, as you can imagine, but those are just some examples of what you may encounter with predictive analytics. Now, the final type of analytics is prescriptive analytics. This takes predictive analytics to really a higher level, and it now becomes a very, very strong decision support tool because it quantifies the various options and allows people to compare the best or more attractive options based on various business rules and various constraints that you may set. This allows you to use multiple tools such as business rules, algorithms, machine learning to pick up trends in the market, and it also allows you to combine and compare multiple data sources such as real-time data, transactional, descriptive, historical big data and other forms. And by using extremely complex techniques, it allows the system to recommend and rank in priority order in line with the various rules that you set up, the best outcomes from a series of decisions. So this is clearly a very, very powerful tool. It's something that's only just really becoming established now, and it's something that's likely to grow in popularity over the next decade or so, and to guide a lot more decision making. So I think in a short webinar such as this, these are the kind of tools that really I'd like to make you aware of. And clearly, if you are interested in these type of tools and looking at them in more detail, there are various information sources that you can use to find out more about these, including some of the seminars that we do at Informa. Let's now move on from the actual big data tools onto some of the trends that we see happening over the next year. So the first trend is what I'm rather cheekily calling a move to smart systems and dumb operators, automation. Of course, we don't really mean dumb operators. What we're talking about here is that at the moment, the big data, especially predictive and prescriptive data setup, requires people with very, very advanced knowledge of econometrics or other big data science techniques. And clearly these skills are in short supply. So what a lot of the vendors are trying to do at the moment is produce systems that automate and make simple a lot of these techniques, almost a sort of drop-down menu approach to building up data models. Anybody who ever used PowerPoint back in the 1990s will remember before it had wizards. It was very, very difficult to use. Many of the other office tools are the same, but these days they all come with built-in wizards and other aids which make it easier to create quite complex presentations, documents, databases and other operations. Yet all we see at the start of it is a sort of very visual series of interactive boxes that allow us to create the results we want. And that's really where we see smart systems trying to move towards, simply to allow more people to use them without requiring this advanced data science knowledge. The second trend is deeper and deeper customer insights. And to some degree, this is a circular relationship. In order to get the deeper insights, people need to understand what the software and hardware is capable of. The more they understand that, relating back to point number one, the more they're going to be able to go in and really start to make that data work hard. It's absolutely unbelievable how much data is available. At the moment, we don't know what we can do with it because we're not aware of the tools and the techniques to deal with that. We see that changing, and we see a big push from the organizations selling big data systems to convince customers to spend more time getting value out of that. And we also believe customers will want to do that because this will lead directly to competitive edge, either by ways of taking advantage of opportunities before competitors or reducing operating costs and thus competitive advantage. Trend number 3, even further democratization of data and data as an organizational asset. At the moment, because of the necessity to have big data science skills, the average manager cannot use big data as effectively as they can use small data, as I'll demonstrate in a few minutes. And once again, the thrust here is going to be towards enabling that. Option number 1 in this trend list also supports number 3. Number 4, what's known as sensor-driven data. Sensor-driven data is literally data generated automatically by a device without human intervention. Just to give you an example, a jet turbine engine as used on an Airbus or a Boeing aircraft can create up to 20 terabytes of data per hour because of the number of parameters being measured and controlled. At the moment, that's not being captured, it's not being used. And if you go back to point number 2, deeper customer insights, capturing that data and using it more effectively may well allow different parameters to be set for operating the engines more effectively, and that could save literally millions and millions of dollars a year in fuel costs for airlines, or it could result in saving millions of dollars in maintenance costs for aircraft engines. So if you put that out, if you look at, for example, smart electricity meters and extend that out to other devices, there's the potential here to capture an enormous amount of data and use that to improve organizational performance without requiring any human intervention at all. And we believe that will become very attractive to organizations. Finally, we believe that the HR department will start to use big data to get much more effective data on employee satisfaction and ergonomics. So for example, the automatic recording of how people work and interact with machines and workspaces, equally how people use workflow systems, whether they're effective or not. And in the same way that aircraft companies design the flight deck to be ergonomically optimum, to have the best workflow to allow people to operate under high degrees of stress, we see similar things coming into the workplace. And because sensor-driven data will allow the automatic capturing of a lot of this information, we see this as being an area where employee satisfaction and quality of life at work will be improved greatly. So those are just 5 of the trends that I believe will be really important. If you look on the internet, you'll find the many ideas. Other people have got some really great ideas. You may want to follow that through and have a look at it. But certainly, as the big data systems become easier to use, as access to information becomes easier for the line manager, there are going to be some really exciting opportunities for people to use big data on a day-to-day basis. Now, if that's big data, what does small data allow us to do? So we have a number of tool sets available, many tool sets available. I present a program for Informa which is called Certificate in Data Analysis Skills, and I typically concentrate on these small data tools. I would like to just demonstrate to you today 3 of the tools that are available to you as managers. The first tool is called Pareto Analysis, And it's based on the frequency of events. So it allows you to look at various events, see which happen the most frequently and the least frequently, and then you can focus on activities such as problem solving or opportunity harvesting based on that hard data. It's a cumulative analysis, so which are the largest opportunities moving up to the total opportunities. Some of the classic uses of this technique are in quality control for identifying the most frequently occurring problems that an organization wants to deal with, product sales analysis, in case people want to look at the frequency of sales and the change in frequency, delay analysis in transportation, cost analysis in organizations. There are all ways of doing this. All you do to do Pareto analysis is you set up a spreadsheet in Excel. Here you have quality control use, various error codings in a process failure. You list the frequency, the number of times this happened. In the first column, in the second column, you can see that we use the cumulative frequency. If I just spotlight this, you can see here the cumulative frequency. And then we do a calculation to produce the percentage of the total errors across in that third column. Now this allows you to see the results, but it's rather dry, and if you want to present this and make it useful, you would tend to have a dashboard approach and you produce some kind of chart like this one. Such as this chart, and you can see here we have basically the error codes. You can see the largest going down to the smallest, and then we have a cumulative line moving from left to right showing us what percentage of total errors we could fix if we tackled those. Clearly we start with the largest opportunities, the most frequent occurring errors. We deal with those first, and then we look at the other errors, deal with those, and that allows us to get the best return on our time by tackling the most frequently occurring errors first. So that's Pareto analysis, and a very, very useful tool, and it's very, very easy to learn as a technique, very easy to set up and make a dashboard, such as the one I've shown you below. The next technique we're going to have a look at is called sensitivity analysis, which looks at a range of numbers when there is any uncertainty about, for example, estimates in a business case. We can look at the downside, the bad things that can happen. We can look at the upside, the good things that may result. And we can start to see our exposure on both sides of the range. We can then identify the impact, and in particular the impact of single factors within a sensitivity analysis. And the potential use for this is strategic analysis of options, developing business cases, and general risk analysis. Again, we set up a simple spreadsheet. We identify what we call a base case, which is what we expect to be the result. We then have a low-end range if things are not as good as expected, and we have a high-end range if things are higher than expected. And we produce some kind of sensitivity analysis such as this one. And you can see on this sensitivity analysis that the red bar here represents a potential downside. We could be driven into a loss on this flight profitability if we don't achieve a certain price for the tickets. On the other side, if we achieve a higher price than expected, we can also increase our productivity. And this so-called tornado diagram allows us to generate an idea of which is the biggest opportunity, which are the biggest risks. Interestingly enough, at the bottom, you can see that the red and green reverse, and that's simply because the the opportunity is to reduce the cost, and the risk is for the cost to increase, and therefore the other areas are about revenues where the opportunities are higher rather than lower. But again, it gives you a very, very clear view of where the opportunities are and where the risks are. I'll just very quickly show you the underpinning spreadsheet behind that sensitivity analysis, which will take a few seconds to load. And I'll show you how this works. So here we have the spreadsheets underneath, which is just loading. Let me make that a little bit larger. You can see here we've got the spreadsheet on the left. On the right we have the bars. You notice the bars at the moment are not in order. That's because we have to format that before we finally make the presentation. But I'd just like to show you basically how this works. You can see here we have some parameters for base expectations, low and high. Now, if, for example, our low sales, rather than thinking we may only sell 100 seats, if we thought we may sell 50, as soon as I enter that figure of 50, you'll see a big change in the graph. The downside becomes potentially a lot larger, which means we have to manage the risk on that very carefully. On the other hand, if the low figure may be $90 rather than 45, we now see we have virtually no downside risk on that. If it was $75, we'll have a relatively very small downside risk. Likewise, and let me just set that back to a reasonable low figure. Likewise, if we manage to sell 220 seats, assuming we had capacity, we can see immediately the upside increases, and if we were able to do a really good promotion and increase the bottom end expectations to selling 75 tickets rather than less, we can see we reduce the risk on that. So we would be able to say, let's run some sales promotions and special offers to encourage people to buy these tickets. So you can see immediately here, this is a very, very useful tool for modeling sensitivity. And then when we're going to make the presentation, we just format the spreadsheet to get the bars in the right order with the largest range at the top, smallest at the bottom. That's called a tornado diagram. And that's because it looks like a wedge-shaped cloud from a tornado. So that's another useful tool and technique we can use. Finally today, in terms of tools and techniques, I'd just like to talk to you about linear programming based on a product called Solver, which comes as a free add-in with Microsoft Excel. It's included in the software but not installed. Here we have a complicated looking spreadsheet trying to maximize combined profit in making various carpets. There are multiple constraints in the cost of yarn, the availability of yarn, production time, backing materials, latex glue, and these are variable, and it would be the sort of calculation to work this out by trial and error would be very, very difficult. Now, fortunately, our tool, which is called Solver, allows us to do this very, very easily. And I'm going to load Solver and give you a demonstration of that. Yeah. Oh, it appears our system is not being cooperative at the moment. So I'll just click that again. If it continues to be uncooperative, I'll just talk you through how it works. Okay. I think we're going to get the demonstration now. Good. Here we go. Let me just maximize the screen. Here we go, that's good. It's just taken a couple of seconds for that screen to maximize. So sorry about that. Let's quickly give you a demonstration of how this works. Basically, we have assumptions here about profit per role and then the resources required. We invoke the Solver tool, which comes under the data sheet, and interestingly enough is not installed on this computer, so this gives me the opportunity to show you how to install it by going to the add-ins in the options screen. We find that we have Solver add-in under the inactive add-ins. So we go to the add-ins, we simply tick the solver box and OK that. The solver dialog box will then appear on the right hand side when that's installed, and we ask solver to pick up and solve this problem. So how many rolls of each of these carpets should we produce to maximize our profit? We have a solution, and solver's telling us that we should produce 121 rolls of shear, nothing of anything else. Now we could work through many different combinations. We could change the number of resources. So if I restore the original values, if, for example, backing latex, if we had 9,000 kilos available instead of 4,000, we can rerun the solver solution and see what happens. And now you see solver is asking us to produce 100 shear and 60 Saxony. That has a significant impact on the profitability. You can alter the combinations until you get the best fit for your business opportunity. So that is a very quick demonstration of solver. It's all there, it's all for free. Takes a little bit of setting up, but once you've set it up, it will solve solutions very, very easily and very quickly. So, in summary, I hope I've shown you some interesting information about big data and small data, and I'd like to now give you the opportunity to ask any questions that you'd like to have answered at this stage. So please, if you have any questions, please feel free to submit them at this stage. Okay, we have the first question through. Thank you for this. The question is, what are the challenges of working with big data? So I think, firstly, there's the systems capability side. It's really very, very expensive area, and you have to build a really good business case based on what you see big data adding in terms of competitive advantage. When you've built that business case, then the next thing will be to find a good partner to work with, someone who can install the right kind of big data systems and help you configure the data, and basically bring that data science skill to bear and help you set it up and make it work. It's a complex operation, and clearly you need some support on doing that. So thank you for that. We've now got a question from Mr. Javed Shaikh about how eventually should I use ergonomics analysis. Well, generally, it's looking at ways of making your operation more efficient. I'll give you a very simple example which wouldn't require big data, but I think it will help you to understand the technique generally. In the old days, textile factories used to typically be built on small footprints of land on multiple levels. This meant as a process was completed, the output work in progress from that product would have to be taken and transported by an elevator from one level to another, and then after that was done, further processing could be applied. That was very manually labor intensive, and that was okay in the days when people had a lot of labor. These days, for efficiency, most organizations in process manufacturing want to automate as much as possible, and moving materials between levels is potentially difficult. So modern factories are designed on a single level with an A to Z a linear flow through for processing. Now, if you collect your ergonomics data within the organization about how people work, where they move for meetings, how they do things, you'll be able to achieve the same kind of outcome in making the operation a lot more efficient, and also increasing the quality of life for the workforce. So that would, in my opinion, be one very good example of how you'd use economics. It's a pleasure, Javed. Thank you for saying thank you. We've got another question. Why does a manager need small data skills? Okay, well, the immediate question that, or immediate answer that comes to mind for me is that managers must be good problem solvers, and anything that allows you to collect data and make better decisions on problem solving is a good thing to have. As I demonstrated, for example, with the solver tool layer, the ability to look very, very quickly at different constraints, different parameters, and come to an optimum solution is very, very useful. What would have taken several days in the past to do manually, now Solver and other similar kind of problem solving add-in packages can do literally in seconds if you set them up properly. Finally, we have a question, what is GoalSeek? Okay, GoalSeek is an add-in within Excel, and it's a simple problem solver. It allows you to put in several constraints, such as, for example, selling price, cost price, unit volume, and it allows you to change one of those parameters at a time, not all of them like Solver. It's therefore a lot simpler to use, but not as powerful. But in some instances, like what would be the impact of changing the selling price on a product, it allows you very, very quickly to say, well, if you change the price to, if you want to achieve an overall profit of $10,000, you have to change the price to this in order to achieve that. So I think those are all the questions. Let me just have a quick check. So that's all of the questions. I'd like to, on behalf of Informa and myself, oh, sorry, we have one more question from Isra Al-Saluli. What do you think is better to handle data, Excel or Access? Wow. I think it depends what kind of data you need to deal with. Obviously, if you're dealing with relational data where you want to capture that and compute it that way, then a lot of people would say Access as a relational database is better. If it's a straightforward matter of just manipulating data from the same source, Excel would probably be easier for that. I think you could argue both ways. Again, we have a question, can you please explain delay analysis? I'm very happy to explain delay analysis. At one stage, I did a lot of consulting in the airline sector. And when aircraft are delayed, it's very, very expensive in terms of extra parking charges and running out of crew hours and delaying flights. So most airlines will analyze delays and they'll look at the causes of those delays, such as, for example, fuel arriving late or engineering not being done or passengers not boarding. And they will try and analyze the root causes of why were the passengers late, what can we do about it, and how can we make sure we reduce the delays so we reduce our operating expenses. And that would be an example of delay analysis. I hope that explains that enough for you. So, unless there are any other questions, again, on behalf of Informa and myself, I'd like to thank you very much for attending this webinar today. I hope it's been useful for you. We'll send you the web links and also the slides as promised within a week. And one day, hopefully, inshallah, I may meet some of you on some of the seminars that I facilitate. In the meantime, let me wish you a very, very nice evening and thank you again for attending. We'll now close the seminar.